Okay, hello. Um, so I guess I should ask first of all, if there's any questions about the final assignment or I haven't discussed the final assignment in detail because it's basically exactly the same as a midterm assignment, except that, questions are different. But if there are questions about that or questions about the final exam, which I was just saying before class, I don't really understand how final exams work. I've never given one before. But, I've taken plenty, but it was a long time ago. Uh, but this one should be pretty simple, you know. Uh, are there any questions about that before I start talking about Kuhn? Okay. So, yeah, the main issue in this reading is to it's not so much about what actually happens during the revolution, although he does talk about that, but it's that's actually pretty chaotic, I guess. Um, but it's more about why there have to be revolutions, right? The title of one of these chapters is something like "The Nature and Necessity of Scientific Revolutions." Um, why there have to be revolutions, and um, that it's not why Popper thinks there have to be revolutions. Right. I mean, it's both of those because he is also trying to defend himself still against this cumulative view, which says that, there shouldn't be such things as revolutions. Science should just build one thing after another, right? Just like keep adding knowledge. As we get more experience, we get more knowledge, and that's how it should work. Um, so he still is arguing against that, but again, at least my understanding of this book is that he's that the main point is to make sure that you understand that this scientific revolution is not the time when scientists suddenly start being free and critical. Um, so right, so the first part, as like arguing against cumulativism, cumulatism? I don't know if that's a word. I just made that up. All right. Anyway, arguing against the cumulative view of scientific progress. Um, and so this is, I don't know if you said one. Anyway, it's against what he calls positivists, or he actually says, I think he actually at one point says early logical positivists. But I'm putting this positivists in quotes because I don't think the position he's arguing against is recognizably like Carnap's position or anyone we read. Um, so I, in fact, I'm not sure whose position it actually is. It's but it's a kind of position that Kuhn at least imagines in order to show why it's wrong. Um, and again, the positivists are he's arguing against them because he's arguing against the cumulative view of scientific progress. Um, and the positivists argue that an old theory is never shown to be wrong by scientific progress. That is, again, the people that Kuhn is calling positivists. They argue that an old theory is never shown to be wrong. I mean, I think I mentioned this before, but I can discuss it in more detail now. So like this is on page 99. Um, this is their argument that that relativity doesn't conflict with Newtonian mechanics. Right? So whereas you might have thought that Einstein, after Einstein, there was a revolution and Newtonian mechanics was shown to be wrong and had to be replaced by something else. Um, the positivist is going to argue that no, actually, there was nothing wrong with the old theory and it's not incompatible with the new theory. So this is how they argue. If Einsteinian science seems to make Newtonian dynamics wrong, that is only because some Newtonians were so incautious as to claim that Newtonian theory yielded entirely precise results or that was valid at very high relative velocities. Since they could not have had any evidence for such claims, they betrayed the standards of science when they made them. Insofar as Newtonian theory was ever a truly scientific theory supported by valid evidence, it still is. So, um, uh, I mean, I drew this before, I think kind of like this. You know, this is the, well, okay. This is the conditions under which Newtonian mechanics is correct. I mean, that's already a misleading way of putting it because it's these are the observations that Newtonian mechanics correctly predicts, put it that way. Right? So like Newtonian mechanics correctly predicts that if uh, I am in a car traveling 30 miles an hour and I throw a ball out the window at 5 miles an hour, it will start off going 35 miles an hour. Right? That's Newtonian addition of velocities. So Newtonian mechanics correctly predicts that up to some accuracy. If you measured it precisely enough, you would find that's not precisely true. Right? You understand why, according to special relativity, that can't be precisely true because that would allow you to make something go faster than the speed of light. Um, right? So relativistically, velocities don't add that way. Um, so, uh, but when the relative velocity, and of course, when I say 30 miles an hour, I mean what? Relative to the surface of the Earth. Because the surface of the Earth is accelerating, but not that much. I mean, you can tell the surface of the Earth is accelerating. That's why, like, ocean currents don't go straight, but start to go this way because the Earth is turning, right? But in your car, throwing your ball out the window, you're not going to notice Coriolis force. It's so we can think of this as like relative to this um, inertial frame attached to the Earth, and um, so you know, and the velocities relative to that frame are low. Right, 30 miles an hour is much less than the speed of light. So so you would have to measure very, very accurately to notice any discrepancy here. So, so that's an example of something that Newtonian can, an observation that Newtonian mechanics correctly predicts. So, and then out here, there's observations that Newtonian mechanics doesn't correctly predict. Right? Like if I'm driving my car at half the speed of light and I shine a flashlight out the window, Newtonian mechanics predicts that the light in that beam will be going 1.5 times the usual speed of light, right? But actually, no, it's the same speed of light in every reference frame. So it gets that prediction wrong and it gets it like really wrong, right? You don't have to make a really accurate measurement. I mean, well, you do because it's hard to measure the speed of light. I mean, no, I guess no, you don't. Right. So, I mean, you have to make a really accurate measurement, like the Michelson-Morley experiment, to tell that low velocities have this effect, right? That like so, in other words, I'm traveling along at 30 miles an hour or 10,000 miles an hour or whatever, and I shine light in two different directions, and I'm trying to measure the difference in speed in the two directions. And the expected difference, according to Newtonian mechanics, is very small, so it's hard to measure. But if my car is going half the speed of light, then the expected difference is big, and it would be easy to measure, right? So here's an, I mean, we haven't made this observation exactly, but we've made observations like it. Imagine we had made this observation. I mean, we've made observations like this in a particle accelerator, right? I mean, there isn't a car going half the speed of light, but there's like a massive particle going half the speed of light, and it decays, right? And you can tell the velocity of the stuff that comes off. So, right. So here's an observation that Newtonian mechanics doesn't correctly predict. And the positivist says Newtonians should never have made any prediction about this because they had no data, right? They didn't have a particle accelerator. They had never seen something going that fast. They should have restricted their predictions to uh, the cases they actually had observed. Because that, like, if you take that literally, that means there are no predictions, really, right? I mean, it's going to be all the cases you've already observed. And, well, it is, right? That is what's going on here is what Goodman calls projection. Keeps being that. But these positivists, I mean, you can kind of see Goodman as trying to show that the real logical positivists would be forced to be this kind of positivist because there is no way to, in principle, to explain what predicates are projectable and which are not. I mean, that is no way they would accept because they won't like Goodman's suggestion. So, um, right. So Kuhn's response to this, therefore, I mean, it's very much like Popper's response to conventionalism. This is on the next page, on page 100. Um, Right. So at the beginning of this paragraph, he says basically what I was just saying, that number one, this 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 prohibits you from making predictions about any conditions you haven't actually observed. And then he says, but really, I mean, if you carry this to its logical conclusion, you shouldn't make any predictions except about the actual cases that you've actually observed. That is, you shouldn't make predictions at all. um, um, But even in its present form, the restriction forbids the scientist to rely upon a theory in his own research whenever that research enters an area or seeks a degree of precision for which past practice with the theory offers no precedent. And then this is Kuhn's response. These prohibitions are logically unexceptionable, right? Again, that's like Popper, right? Popper says conventionalism is logically coherent. You can do this if you want. Kuhn says these prohibitions are logically unexceptionable, but the result of accepting them would be the end of research, the research through which science may develop further. Right? And it's like conventionalism in the sense that you um, your theory becomes unfalsifiable. Right? Like if you practice science to the standards that the positivists are requiring, then you can't possibly go wrong. So you can't possibly have to give up your theory in the face of new evidence, because the new evidence will always be about something that you never said anything about. And as Kuhn says a little bit farther down, um, without commitment to a paradigm, there could be no normal science. Furthermore, that commitment must extend to areas and to degrees of precision for which there is no full precedent. But um, but first of all, positivism is not conventionalism, right? These are two completely different approaches. Actually, the positivist, there's no stratagem here, right? There's no like I say this falsifies your theory, and the response is, oh no, but you didn't understand my theory correctly. Blah, blah. It's just like if you have to be careful to never predict this at all. Um, um, and second of all, like the reason the non-logical problem, right? That is um conventionalism or positivism is logically unexceptionable, but there's a non-logical problem. But the non-logical problem is different. Um, so for Popper, the non-logical problem, the science has to make bold claims in order to risk being wrong. So that's why we need projection. Um, so that's why, and this is why this comes out as an argument against conventionalism. I can't understand the statements of my theory in such a way that they couldn't be wrong. Um, because I need to, my theory is no good unless it runs a risk. But that's not why Kuhn says that science requires projection. So let me finish reading what I started reading before. Without commitment to a paradigm, there could be no normal science. Furthermore, that commitment must extend to areas and to degrees of precision for which there is no full precedent. If it did not, the paradigm could provide no puzzles that had not already been solved. Right? So here the problem is that it's not that the theory has to risk being wrong. It's that uh, the theory has to leave open places for scientists to work on showing that it's right. If the theory has already been shown to be true of all the cases to which I'm allowed to apply it, then it's no fun. Because there's no puzzles. What am I going to do with it? And since remember, at least insofar as scientists care about it, it's not useful for anything necessarily. Uh, it's if it doesn't provide any puzzles, there's no reason to think about it at all. So that's why every theory has to make these kind of bold predictions, not because it needs to run the risk of being wrong, but because it needs to, again, it needs to provide places where you can try to show that it's right. Right. So like if Newtonian celestial mechanics had stopped with predicting that up to a certain accuracy that orbits of the planets will look like ellipses. And he checked, and up to that accuracy, they don't do like look like ellipses, that would be the end of Newtonian celestial mechanics. But instead, it made much stronger claims, right? That if you measure very, very accurately, you'll be able to, it won't be precisely an ellipse, but you'll be able to predict what precise shape it was by knowing the real distribution of masses in the solar system, right? But Newton didn't finish that. He at least implicitly made that claim. I guess you could say he explicitly made that claim. I mean, he he didn't qualify his predictions by saying, oh, this is only true up to some level of accuracy or whatever, right? And then it was up to his successors to bring the observations of the solar system into accord with the theory. And those were the puzzles they had to solve. But according to Kuhn, it's just a byproduct of that. It's not what the scientists intend. It's a byproduct of that. That uh, um, that there is a risk of showing that the paradigm theory is wrong. Not exactly that it's wrong, but that it's unusable, right? Because the puzzles can fail, can stop being fun to solve. And when that happens, we need a new paradigm. And um, so it's not intended, but it's a byproduct of it's, you know, if we could be like the positivists say we should be, then there would be no puzzles and there would be no danger that we would stop being able to solve the puzzles because there would be no puzzles. But since there have to be puzzles, there has to be a danger that we might stop being able to solve them, even though scientists, that's the last thing they expect, right? They've been trained rigidly to expect that if they follow these rules, there will be a solution. But um, there was no justification for that. There was no reason to expect that. And, you know, so eventually uh, it can fail. I mean, there's something a little bit, there's something a little bit mysterious about the point of view Kuhn is taking here, right? Like, how do we know it always eventually will fail? Why should we think that?
Not that we might eventually get the perfect paradigm.
Yeah, that another bit where by perfect we mean, so again, like the paradigm, and like this only becomes apparent in the period of extraordinary science, but the whole while it wasn't clear exactly what the paradigm was, right? That's why there's this problem of paradigm articulation. It wasn't clear exactly how we were supposed to apply the paradigm to new situations. Um, so um, how do we know that we won't always be able to keep doing that? Right? I mean, there seems to be like an assumption here that you know that's very improbable or something, right? Like it's very improbable that our paradigm would just happen to only propose always puzzles that can be solved. Why would the world cooperate with us on that or something like that? But that, you know, which I mean, when you say that, it sounds right, except then you have to be taking a kind of metaphysical view from outside of any scientific way of understanding the world to say that. Um, all right, but anyway, like I said, it sounds right. You know, the paradigm has to risk, has to have this risk, not again, not because they're because scientists want it to run a risk, but because what they want it to do is like against their will happens to be risky. Um, okay, so the way this difference between Kuhn and Popper shows up then is that is, I mean, so they both agree that the cumulative theory is wrong, right? That is, both Popper and Kuhn agree that the new theory is going to explain something which the old theory claimed it could explain, but it failed, right? Like the old theory said, yeah, I can predict what color swans will be in Australia. All swans are white, so swans in Australia will be white. um, but it failed. It turns out no, they're black, right? And the new theory is going to explain that thing that the old theory claimed it could explain, but failed to. And so the old theory and the new theory are somehow incompatible, right? The new theory doesn't just add on to the old theory. The old theory failed, and the new theory is supposed to succeed at the same thing, right? So, like going back to this observation out here, we're now thinking, the old theory did predict something for that, and it was wrong. So the new theory is incompatible with it. Um, but uh, so I guess should I erase this? Uh, um, so Popper and Kuhn agree that the old theory is incompatible with the new theory, but um, Kuhn adds that in general, the new theory is incommensurable with the old theory, right? So incommensurable means, so literally incommensurable means it's like two lines are incommensurable if they can't be measured by the same unit, right? So like this is a right angle. Um, so the length of both of these is one, and the length of this is the square root of two. So no matter what unit you choose to measure this, if it comes out even for this, it won't come out even for this. People know that, right? Okay. The square root of two is irrational. Right. So this line is incommensurable with this line. That's what it means literally. But Kuhn is using it to mean that, I mean, I guess so, you can say in this situation, um, you can say that the square root of two is bigger than one, but you can't say exactly, um, you can't compare it in detail to one. There's always some, there's always some like leftover part that you haven't accounted for. Um, so Kuhn is using it to say that the new theory and the old theory, um, they don't just conflict with each other. And that the new theory says, that there's something that the new theory says is true and the old theory said was false. Rather, they make claims that can't be compared directly with each other at all. That's right. So this is a stronger type of incompatibility. They both, Popper and Kuhn, agree that the old theory and the new theory are going to conflict in the sense that, you know, um, the new theory doesn't just contain the old theory and add on to it. But but according to Popper, that's going to be limited to the fact that, you know, for some cases, the old theory and the new theory make opposite predictions. Right? One of them says white swan and the other says not white swan. But for Kuhn, the old theory and the new theory are going to be talking past each other. Like there's going to be an observation, there's going to be a prediction that the old theory makes. And you're going to turn to the new theory and say, what do you predict about this? And the new theory is going to say, I don't understand the question. um, so why does this difference happen? Um, I mean, I think like to understand it, you have to compare the way the positivist, maybe I shouldn't have raised the positivist. Is Kuhn's positivist versus Popper's conventionalist. Popper. This is Kuhn. Like, um, compare in detail the way they would say of an old theory in the face of new evidence. So, um, like consider this is an example that Kuhn discusses the original, like the Ptolemaic theory of planets versus the Copernican theory of planets. So, like, what happens in the change is that um, um, well, I mean, so two things happen. Number one, in the Ptolemaic theory, we'll have to like it's still use people circles there. That's same as something else. So, right in the old like Ptolemaic theory of planets, all the planets move around the Earth. Actually, I mean, in the real Ptolemaic theory, they move in these weird epicycles for them.
Really pretty.
What's that?
It's really pretty. Frankly, I really wish it was true.
The epicycles?
Yeah, they look so nice together. They look like a big flower. The real solar system's really boring. I don't know. There's a lot of stuff in the history of astronomy where people are like, wouldn't it be beautiful if the heavens were like this? And then, of course, it's not. It's way shittier than that.
Well, so I mean, the like
They don't play music.
no, like so the original Eudoxan theory, according to which Aristotle still thinks will work, according to which everything here moves around the center of the Earth, was definitely adopted. Can I say it was for that reason? I mean, it was. Uh, it's kind of the first thing that would occur to you, right? You look up in the sky and it looks like everything is just moving in circles. but but anyway, it was yeah, it was assumed this had to be a circle because it's symmetrical and whatever. Uh, Once they started adding those epicycles, I mean, I guess it looks kind of fancy or something, but like it actually was that was actually a thorn in the side of astronomy, right? Like according to Aristotle, this is impossible. And moreover, it's a little bit hard to understand, right? Like these are supposed to be solid spheres, so how can there be a little one rotating?
Oh, I forgot that part of it.
Yeah.
It's supposed to be nested spheres because there's the whole.
Yeah. So, like, it was never really very.
That big too.
It was never really. It was these were necessary to explain observations, not so that they like. Wouldn't it be nice if the universe looks like a flower? It was like, but sometimes it moves the other direction. How can we explain that? So, uh, but okay, so one of the changes going to the Copernican theory, let me just go straight from Eudoxus to Copernicus, skipping the epicycles. right? So one of the changes is that we say that the planets no longer go around the Earth, they go around the sun. Um, and so um, Popper's conventionalists, right? So like we found that this is not true. Rather, something else is true. All the planets go around the sun, and so does the Earth. That, yeah, that's visible. Um, so Popper's conventionalists, like, how are they going to say that the old theory wasn't falsified by the new theory? Well, so they're going to say, by definition, a planet is something that moves in a circle around the center of the Earth. Right? They're going to make that part of the definition, right? The theory is going to implicitly define its terms. So when the theory says, when the old theory says all the planets move around the center of the Earth, we're going to see that as a definition of planet. Well, at least a definition of planet and circle and Earth and around, right? Like all the undefined terms are going to get defined by the statements like that in the theory. So what are they going to say about this picture? Well, I mean, I think they actually have a choice. That's why conventionalism involves these stratagems, right? Like there's different ways you can apply this actually. One thing they could say is, well, obviously then this is a circle around the center of the Earth. Right? Because the terms circle, center of the Earth, around, and whatever are implicitly defined by the theory. And so if this is what a planet does, then this is a circle around the center of the Earth. Or they could say, oh, it turns out there are no planets, except maybe the moon. There's like one planet. Right? So, um, so the key cases here are for the conventionalists, or the key cases that Popper wants to save from the conventionalists are the cases of the Earth and the other things that we still call planets, like Mercury, Venus, Mars, right? We want to show that, the statement that the Earth doesn't move and Mercury moves in a circle around the center of the Earth, those judgments, those statements have been falsified. That's what Popper wants to argue. So that's what he's defending against the conventionalist.
I remember thinking when we were like reading about phlogiston.
Phlogiston, I think it's pronounced, yes.
I've always thought it's phlogiston like a country in Central America. Anyway, it seems sort of arbitrary because, like, I remember reading this bit in Popper that's like, the scientist who tries to keep the concept by just changing what it means is doing science bad. And clearly sometimes we think that's okay because we still say planet. But then like phlogiston used to be the name, phlogiston used to be the name for the thing that makes combustion happen. So we could just as well say, like we could have named oxygen phlogiston and said that phlogiston is real and just changed our concept of it. So when is that okay and when is that not okay? It seems kind of arbitrary. Well, Popper must think it's okay sometimes, or we'd be inventing new terms all the time.
So Popper thinks, this is exactly why Popper thinks concepts don't matter. Terms don't matter.
Yeah.
It just matters whether you're saying something that you're willing to give up, right? So that like the whole statement, Mercury moves in a circle around the center of the Earth. When you see this picture and here's Mercury, you have to say, oh, this was wrong. I have to give it up. Whether you decide to change the meaning of the word planet or whatever, according to Popper, is not important.
This reminds me of deific theory, theology.
Day epic.
Yeah, it's a whole, the Bible says the earth was created in 7 days, and there's a school of theology that says that can be weirdly
Oh,
Greek.
that day epic.
If you think day means something very specific for God.
Yeah. Okay, but I mean,
It's not, yeah.
that's not exactly the same thing. But anyway, right. So, I mean, so that is part of what Popper thinks the conventionalist is doing wrong is focusing so much on the concepts.
Yeah, yeah.
Um, so whereas uh, for for Kuhn, the the key cases here are the moon and the sun. So according to the old theory, the moon and the sun were planets, right? Like the first planet was Mercury and then Venus, and then, well, no, actually, that's not true. The first planet was the moon, then Mercury, then Venus, and then the sun. So, so among the things that we call planets, because they move in circles around the center of the Earth, were the moon and the sun. Um, and Kuhn's positivist is going to say that what we should have used the word planet to mean in the old theory is things that seem, if you only do certain measurements, only up to a certain precision, as if they're moving in circles around the center of the Earth. And so we can say these are all still planets. Even though we switch to this picture, we can say these are all still planets because yes, they're really moving around the sun, and the sun is in the middle, and it's not moving around the Earth, whatever it's doing, and uh, um, and the moon is moving around the Earth, and the others, right? Like they're all doing different things, but they still have in common that if you only make the measurements that the ancient astronomers made, and only up to that accuracy, then it looks like they're moving in circles around the center of the Earth. I mean, like it's more complicated. Obviously, Eudoxus already knew that sometimes the planets move in retrograde. That was it's not like Ptolemy discovered that. It was the motions of these spheres are supposed to actually add up as you go out. And so by having like different spheres rotating in different directions, you can get a planet moving in a more complicated way in the sky. But never mind that. Let's just say, up to that measure accuracy of their measurements, it looked like the planets were moving in a circle around the center of the Earth. Um, so that's what they meant by that's what they should have meant by planet, and that's what they should have said about the planets. And so this new theory doesn't contradict anything they said. The moon and the sun are still planets, and um, um, all planets seem to move around the center of the Earth. So, it is basically the positivist strategy is to always subjectivize the concepts you were using. Right? Like I meant up to the accuracy of my observations, it seemed like, at least that's what I should have meant. Um, and so, I mean, in a way, it's the same strategy that Descartes' meditator, you know, follows in the second meditation, where, it certainly seemed like I was seeing something. That couldn't be wrong. Um, so for Popper, the moral of this again is no, we better make judgments in such a way that this change of pictures can lead us to say that our old judgment was false. And again, it's because we want to put our theory at risk. That is, we want to have to admit that our old theory was false. We have to use the statements of our theory in such a way that this kind of thing can show that they were false. So I have to not regard that as that as a definition of planet or whatever. Um, for Kuhn, the moral is that we have to use our concepts, like the concept planet, for example, in a way that will allow them to run up against anomalies that can't be solved. Again, not because we're looking for anomalies that can't be solved, but because we're looking for, so to speak, anomalies that can be solved. Right? There always have to be anomalies because otherwise there'd be no puzzles. So we want anomalies that can be solved, but therefore we must intend our concepts in a way that potentially creates anomalies that can't be solved. So for example, the concept planet must be intended in such a way that at some point it will become too difficult to stuff nature into that box. And it becomes too difficult because uh, we find that the sun and the moon will no longer fit. So we don't have a box for them anymore. And now it is important that we keep using the term planet. We keep using the term planet, but it can't mean the same thing that it did before. Right? That is, we had to use it before in a way that would, under some circumstances, make it impossible to keep using it that way. And and again, this is the circumstance, right? Where like um um maybe not explaining this that clearly, but like uh um the old meaning of the word planet that included the sun and the moon is not a useful concept in the new picture. The sun and the moon are not like the other things that we still call planets. And whereas for Popper, that makes no difference. Define your terms however you want. For Kuhn, that's that makes a huge difference because it means that the boxes that you're trying to stuff nature into have to change. Yeah.
This is a more question about conventionalism generally, but does Popper believe that our definitions have to be about a specific trait that something has? Like your description of lead being about something that melts at this temperature. Like, can we be referring to a thing in itself, not like in the Kantian way, but like the term for lead is all the things that are lead instead of all the things that have the property that lead exhibits?
Well, I mean, in effect, so like in effect, that's what Popper thinks we should do, right? I mean, I wouldn't put it exactly that way, but the point is we should use the term lead such that the properties we think lead has could turn out to be wrong about it. Right. Whereas Popper's conventionalist says, and I mean, Popper's conventionalist, it's not just a strategy to protect your theories, right? I mean, as I explained when I introduced conventionalism, it kind of emerges out of, as Popper himself explained, it kind of emerges out of a puzzle of like, so how could our terms be defined? They must be defined implicitly, right? And precisely because, yeah, you can't say, it's not a definition to say lead is all the things that are lead. Right? So what can you say? And, I mean, Uh, if we read Putnam's paper, the meaning of meaning, you would see a lot of stuff about this in there, about including examples with metals and mostly like thought experiments, like people in two countries next door to each other. And they use the same word for metals that they can't distinguish from each other at that stage of development, but they're actually not the same metal. And when their chemistry gets more developed, they're able to tell that they're different metals. And then the question is, did their words, used to mean the same thing and now they mean something different? Or did they always mean something different? Um, yeah, it's questions like that. So, I mean, so like Popper doesn't, I don't think, because again, Popper thinks it doesn't matter that much exactly how this works. As long as you're taking a risk in your statement, is not that interested in, so how do we actually know what lead means? I mean, I think Popper could say its meaning is the risk we're taking. I don't know, does that help?
Yeah.
Okay. Um, so, um, and this is why, according to Kuhn, normally the new theory will not only be incompatible, but incommensurable with the old theory. Because what broke here was not the system of statements that we think are true. What broke here is the system of concepts that we think apply to the world. So we've had to change that. And therefore, I mean, of course, this is a very simple example, but it is an example, right? Like when the Copernican talks about planets, that like the extension of the concept of clay has changed. It's not the same concept anymore. So the Ptolemist or Eudoxan or whatever you have over here, when they say something about planets, they're not talking about the same thing as the Copernican when they're talking about planets. Um, so, um, and this can happen. This has to be able to happen, according to Kuhn. That is a human creative activity in which this couldn't happen wouldn't be science. It wouldn't be normal science because, again, the theory can't say exactly how nature is to be fit into the boxes it provides. If it's said exactly, then there will be no puzzles. So there has to be some um, room for finding out that actually there's no way to put it in. Now, I mean, when I say there's no way to put it in, I mean, that's an exaggeration, right? I mean, there is a way to put it in, but it's not a satisfying puzzle solution anymore. Um, so in effect, there's no way to put it in. And that has to be something that can happen. It has to be something that can happen because again, the theory has to leave these cases the paradigm really, we should say at this point, has to leave these cases where it hasn't given you complete instructions about how to do it. Um, but that also means the theory hasn't given the paradigm hasn't given any instructions about when to give up on stuffing nature into these boxes. Right? Like just like the rules of jigsaw puzzle solving don't tell you when to give up and decide this isn't a jigsaw puzzle after all. They can't address that case at all. Does that People are looking not happy about that. Does that make sense? Right? Like you can't imagine buying a puzzle in a box and you read the instructions in the back and it says, do this, do this, do this, and then it says, if this happens, you should conclude that actually this wasn't a puzzle and you can't solve it. Right? That people wouldn't buy that kind of puzzle. So, the paradigm didn't leave any instructions for like when an anomaly is intolerable. I guess I should have said, I should have said, it's not so much that there always will be a way to stuff it in, but it might not be satisfying, is that you can always set the problem aside as too hard. Right? Remember, that's always an option. So, if like at a certain point, Ptolemaic astronomy was having great difficulty explaining certain things, especially like, I mean, it wasn't just that there were too many epicycles, although people were very uncomfortable about that, but there was like to explain the orbit of the moon, they introduced so much machinery that the distance between the Earth and the moon would vary considerably as it went through its orbit. And you can look at it and see if that's not true. It's always the same size. Right. So, but a response to that could have been, well, like, we can only predict the motion of the moon so well. There's certain things we can't account for without introducing machinery that doesn't seem like there's space for it or whatever. And so, that problem is too hard. Maybe someone else will solve it later. That could have been the response. Why wasn't that the response? I mean, Kuhn suggests that it was partly because of the demands for calendar reform, that people really wanted to know. So, I mean, of course, our calendar is a solar calendar, except for calculation of the date of Easter, which is lunar. Right. So that created a lot of the problems here. uh, so I don't know. I mean, Kuhn isn't very insistent about that, and I don't know if it's true, but he suggests that that's one of the things that made all attention draw to certain anomalies. So the point is, since the paradigm doesn't give me instructions for when to give up, the paradigm hasn't been falsified when the new paradigm takes over. Right? It's not like the old paradigm admits, as opposed to a Popperian theory, right? One of Popper's theories says precisely, this is when you should give me up. That's the whole point of it. Give me up if the following things go wrong. This one doesn't leave any instructions like that. So no matter what happens, this one still says, no, keep doing it. So there's no falsification. Um, okay, so again, I mean, like, we're not to summarize this, but the main point of it was to explain why, like, on the one hand, how much Popper and Kuhn have in common here, right? Like, they both think that for science to make progress, it can't be this positivist or conventionalist thing that never runs a risk. Right? They think that for science to be science, it has to run a certain kind of risk, but they disagree about what kind of risk that is. And they disagree about like why science has to run that risk. And they disagree about what the result is going to be. And, I mean, those disagreements add up to a big disagreement because whereas the Popperian scientists are deliberately running a risk in the hopes that they'll be able to reject this theory and come up with a better theory, the Kuhnian scientists are addicted to puzzle solving and are forced to scramble to find new roles for puzzle solving when the old ones stop working. They don't know why. um, All right, but having gone this far, right, other questions before I go on? Because I'm gonna start something else. Yeah,
Of a stupid one,
I doubt that.
genuinely, which is that I think, I mean, think people might buy a puzzle that might just go wrong, a jigsaw puzzle that might just go wrong. Could you imagine combining like scratchers and Sudoku? Um,
It strikes me that
I mean, I don't think that would be like acceptable to a scientist, but I do think someone could get addicted to that exact sort of thing.
I see what you're saying. But yeah, maybe the analogy's not exactly right.
Yeah, but the Sudoku.
I mean, but like, I mean, suppose the puzzle says, the instructions say, uh, we sell puzzles, but we don't know if, and these are the rules for solving them, but we don't know if puzzles can actually be solved by these rules. Right? So like, maybe none of them
it's like a board game that's just a piece of cardboard and a box of toys.
Well, no, because it's worse than that, because it's like, it's telling you, do this to solve the puzzle. But by the way, there's no reason to expect that there is a solution like that. And like, and if you don't find one, yeah, we were probably wrong. Maybe none of these puzzles could be solved. I don't think people would buy a puzzle like that. Yeah, I understand, like, it's, yeah, maybe they would buy a puzzle where like sometimes you can't solve it. But yeah, I don't know, maybe it's worth thinking about. What is it? Is Kuhn really right about, like, why do people get addicted to puzzle solving? And why do we say, this is something I wrote about somewhere, but I'm not sure I'm right about it. Why don't we talk about people getting addicted to like competitive games? I mean, to like competitive games of strategy. Seems like that's, people like it, but it's not an addiction. Yeah, you've listened, yeah.
Um, well, one of the things that I had taken from this like particular section of the readings, was that like, it seems like if you take his interpretation of paradigms as necessary for understanding the world in any way, or like necessary for perception, I should say, because that's almost like identical to what it says. You might be able to like go from that to see a different motivation that he might try to put forward for the movement to another paradigm, because otherwise your perception of the world is all jumbled, and that kind of like ties into one of the quotes that he had about, from a scientist about, I think it was Pauli, about one of the revolutions. He wrote to his friend that everything was like all tossed up, and it seems like it would be a more serious profession would have been to become a what is it, a screen comedian.
Movie comedian, yeah, that's what it says. Well, yeah, I mean, yeah, the question about that application of it to perception in general, I mean, because perception in general doesn't have all the characteristics of normal science that he mentions. So I'm not sure exactly how far that analogy is supposed to reach. Um, um, like, for example, we do try to perceive things that are useful to perceive, not just things that someone told us in advance were perceivable. So it's, I mean, but I think it's true that he thinks the scientists, I mean, look, when Pauli is outside the laboratory, his perception isn't literally all jumbled up. um, but he's experiencing something like what you would experience if you put on those reversing glasses or whatever, right? Like everything doesn't look right. There's supposed to be an analogy between that and and that is what's, Well, look, I mean, maybe the relevant issue is this. You can quit being a physicist and become a movie comedian. You can't quit being a perceiver, right? Like there's no way out. So that distress that you have is like incurable except by learning to perceive the world in a new way. But the scientists, the distress they have is only because they want to continue in this profession. And then the question is, why do they want to continue in this profession? And that's where the addiction motive is supposed to come in. Right. So I think that's why there isn't, in the case of perception in general, there isn't great. You don't have to ask, like, why do we keep perceiving things? Are we addicted to perceiving things? We have no choice but to perceive things. That, I don't know. Does that, I'm,
You know, I think we just have different views of that, like.
yeah, maybe.
The subtext in that, but I mean, it's understandable, it's not no doubt.
No. But at least I'm pointing out, at least I'm pointing out that you have to be careful about applying that analogy back and forth because it seems like it's not precise. And I don't think he claims it's precise. But he does claim it's suggestive. Yeah. And also I think he thinks if we understood perception better, we would change our epistemological paradigm and then maybe we would find some better way to describe, especially the stuff I'm about to talk about. But yeah, I think that's as far as it goes. Yes.
Think that we ever like have figured anything out. Like I doubt that the Copernican like solar system is gonna be disproved ever. Like I think that's pretty settled. And maybe I'm just so deeply within the paradigm. But will there always be a revolution? Or is there something that has enough accordance with reality that at least we would never figure out another?
So I mean, that's kind of what I was talking about earlier. How do we know that there's definitely going to be a revolution eventually? He doesn't really have a strong argument for that. It's more, I mean, he shows why there must be a space where it could happen. But why we should think it probably will happen, I don't know. But as far as the Copernican solar system, I mean, again, there's a little bit of a, like, the Copernican solar system, the way Copernicus understood it is long gone. Hey, so I mean, it's not like anyone thinks the center of the sun is the center of the universe.
Copernicus thought it was all circles, right?
Copernicus also had and I think Copernicus had epicycles too, actually. Right?
Not being circles is kind of important, as I
Yeah.
understand it.
Yeah, no, it's very important. And I mean,
Yet
but
again, it gets ugly.
but like the theory of gravitation, which is central to how we understand what the solar system is obviously Copernicus and Galileo didn't know about that. And Kepler, none of them knew about that. And meanwhile, like our theory of gravitation is no longer Newton's theory of gravitation, which wouldn't explain the orbit of Mercury and whatever. It's something completely different. So yeah, I mean, there have been revolutions in our understanding of the solar system since then. But you shouldn't, I mean, there's going to be a chapter coming up called The Invisibility of Revolutions that explains why looking back from after the revolution, you can get this impression that science was cumulative. And so that's probably the right time to talk about this after I read that. Okay, but let me get back to this, which is, so like, once we understand why this happens to scientific concepts, according to Kuhn, I think going back to the more general meaning of paradigm, we can see why it's not only concepts that this happens to. There are, so to speak, more fundamental types of incommensurability than just, oh, what we mean by planet is not the same as what you meant by planet, or what we mean by velocity is not the same as what you meant by velocity, or whatever. So, one thing that that can change between the old theory and the new theory is um, standards or methods. Um, uh, Problems that are considered legitimate, right? So like Kuhn discusses, and I think this is a very important example, the the problem of like predicting the qualities of compounds. So like this was something people tried to do, although it was difficult. in but phlogiston theory, for example, made some progress in this direction. Right? So, because remember that phlogiston theory said that all metals are a compound of an earth plus phlogiston. So when you ask why are all metals similar, they're all shiny and ductile and whatever. I guess they're not all ductile, but anyway, whatever. Why are all metals similar in certain ways? The answer was, well, those are properties of phlogiston or something like that. They're explained by phlogiston. Now, I mean, that only takes you so far, but it's somewhat of an explanation. And that Kuhn says that after the chemical revolution, chemists decided that that kind of question was not scientific, basically. Right? That if you want to know why, when you combine hydrogen with oxygen, you get this liquid that, um, freezes at a certain temperature and whatever. Uh, that's not something chemistry can explain. So a whole type of problem that was a legitimate puzzle in the old paradigm has now become non-legitimate puzzle. So, right, this is a more fundamental type of incommensurability because the old paradigm will say, well, look, I can explain this. How do you explain this? And the new paradigm will say, well, that's not a good question. Um, I mean, you can see like, although it didn't, this is an oversimplification in several respects, but you can think of Aristotelians thinking that if something is moving, you have to explain what's moving it. Right? So either it's moving by its own nature or something is pushing it. And then there's this problem. What about projectiles? Why are they moving? And like Aristotle and older Aristotelians tried to explain that by the air moving around it or something, but in the later Middle Ages, as Kuhn discusses, they came up with this theory of impetus, which suggests that there's a kind of uh, um, I don't know, force that the projectile builds up when it gets farther away from where it started. And that's what's pushing it. That's why it's still moving. And from the point of view of Galileo and people after Galileo, there is no question why something is moving. Right? And to the point where in Newton's laws, it becomes as Kuhn would say, a tautology, right? A body in motion remains in motion until acted upon by an outside force. Meaning, if nothing's happening, you expect things to move. That is, you expect them to keep moving the way they were. You can't ask, why is it moving? So where the Aristotelians, like the Aristotelians will say, well, look, like we can explain why um, um, this body isn't just sitting still, it's moving. How do you explain that? And the Galileans will say, well, like, so for example, the moon, right? Why is the moon moving? So according to Aristotelians, it's because the natural motion of the celestial substance is around the center. So it's following its nature, and that's why it's moving. How do Galileans explain why the moon is moving? There is no explanation. There's after Newton, there's an explanation of why it's accelerating towards the center, right? It's accelerating towards the center due to the force of gravity. But like, if it weren't moving, it would also accelerate to the center due to the force of gravity, and it would just smash into the earth. So why is it going this way? There is no answer. Right, so like, because again, the answer is, well, why wouldn't it go that way? It was going that way before. So, um, I mean, there's other questions in this area that you can ask, right? Like, so, you know, but never mind. That particular question just doesn't have an answer anymore. And so again, it's incommensurable. The Aristotelians will say, well, how do you explain this? And the Galileans will say, well, that's not a good question. So this is one deeper kind of incommensurability, but and there's other things like this, and it makes, Kuhn says, it makes the arguments between the paradigms circular in the sense that each paradigm is proposing its own standards for what a good question is and what a good answer is, and is showing that it can meet its standards. And when you want to compare them to each other, there's no external standard that you can use for both. That, again, I think maybe that's really, maybe I didn't explain it right. Maybe that's really the metaphor of incommensurability terror. There's no unit that you can apply to both of them. That also wouldn't be a very nice metaphor, but maybe that's what it means. Anyway, there's no external standard that you can apply to both the old and the new paradigm, right? There isn't a list like a quiz where you can ask them both to answer a whole list of questions and then tally up which one got more right, because they don't accept the same questions. Like, they give themselves the quiz. So, but it gets worse than that. And this is like the coolest and weirdest part of Kuhn, where he starts talking about how the two paradigms are in different worlds. Nature itself has changed in the paradigm shift. And this is what, you know, leads to people to say that Kuhn is a relativist. That is a cognitive relativist, which would mean saying that like, you can't say what's true absolutely. You have to say what's true relative to some paradigm. And sometimes he says things that sound like that, and sometimes he tries to qualify them. But I think, I mean, to understand what you think is going on here, I think it's like it's useful to look at this one example that he gives, and this is on page 134 and 135, about where he says that after so this is a different, after the Daltonian revolution in chemistry, the numerical data of chemistry started to shift. Right, so the numerical data in question is like, if you ask what weight of constituent A combines with weight of constituent B to form a certain compound. And according to Daltonian chemistry, which says that compounds are made of, the smallest particles of compounds are molecules, and each molecule contains a certain number of atoms of one kind and a certain number of atoms of another kind, and so forth. right? And so if all the atoms of the same kind always weigh the same amount, there has to be a fixed proportion of weight that so to make water, you need 2 hydrogen atoms for every oxygen atom. And hydrogen atoms weigh 1, and oxygen atoms weigh 8. So, this weighs 2 and this weighs 8. So like if you need if you want to form water and you have 8 pounds of oxygen, you need 2 pounds of hydrogen. So it has to be a whole number, and it has to always be the same. But Kuhn says, like, before that, in pre-Daltonian chemistry, there were no observations. There were scattered observations that showed that in some particular reactions, you had to combine the ingredients in certain proportions of weight. But there were lots of other cases where that didn't happen, and people didn't necessarily think that was an important phenomenon when it did happen. And so part of the reason is back to this thing about the change in concepts. The pre-Daltonian chemists, for example, counted salt water as a compound of salt and water. Right, so the meaning of the term compound has changed. So Daltonians will say salt and water is a mixture. There's no compound. And that's why there isn't a fixed proportion. Right? You can add a little bit of salt to the water, you can add a lot of salt to the water, and you still get salt water. But just it's like more salty or less salty. And so if you put that in the same category as mixing hydrogen and oxygen to get water, then you'll see, yeah, some compounds maybe need a fixed proportion, but others don't. But so one thing that happened after Dalton is that the line between compound and mixture was redefined. Just like this difference between planet and not a planet got redefined, right? But Kuhn says, moreover, the actual measurements of how much weight of X you have to mix with how much weight of Y to get a certain compound started to change. Now, why did that happen? Kuhn says it wasn't a magic. Right? It's not because the scientists had a new paradigm that suddenly made the atoms behave differently or whatever. And it wasn't, he doesn't think it was cheating either, I don't think. I mean, I was talking to Terry about this after the end of lecture last time, that, there actually is a fair amount of fudging of data in the history of science. And there's still a lot of fudging of data in science now too, I think. Right? You find certain outliers that you don't know how to account for, and you just kind of like, take that out. So, but Kuhn doesn't think that's what's happening in this case. What is Kuhn's explanation? This is what he says on page 135. It is hard to make nature fit a paradigm. That is, it's hard to make these precise measurements of how much weight of each constituent you need to form the compound. If you have no reason to expect that it has to be a whole number and it always has to be the same, you're gonna accept a result that doesn't support that. But if you know because of your paradigm that it has to be that, then you're going to keep working. Make your instrument more precise and whatever until you get an acceptable result. So, like, I guess you could put it this way. From the point of view of the new paradigm, we can explain without evoking magic or cheating why this happened. People were trying harder to get accurate measurements, and so they got the right ones. End of story, right? But if you're trying to compare the two paradigms, the older paradigm just doesn't have the data you have. They have different data. Their data just doesn't support your theory. And the theory, the data does support the theory, didn't appear until after the theory was accepted. So it could be a reason for judging between the two, right? So that again is a sense, that's a sense in which they're living in different worlds. They observe different things. And so you can't ask, like, why don't they accept that their theory is falsified? Their theory isn't falsified by their data. It's only falsified by data that could only have been collected under the new paradigm. So Kuhn, I think, Kuhn hesitates. Should we say, Kuhn says, well, he introduces this quasi-technical distinction between looking at and seeing, right? He uses, if you pay attention, you'll see that he uses these terms over and over. He says that, the two scientists are looking at the same world, but they don't see the same world. Right? So like when he's talking about, I think this is about the discovery of Uranus. I'm not sure. Astronomers saw new things when looking at old objects. Right? Like, this is kind of a minor revolution, but I think within the specialized field, Kuhn thinks it is a revolution. It was part of the old paradigm that there are 7 planets. And, or I guess, wait. Yeah, there are 7 planets. And whatever's not a planet is either a comet or a star, right? So, the discovery of another planet was like revolutionary from their point of view. And it turns out that that astronomers had been looking at it more, right? That is, if you go back, and in those days, it was by eye, but these, you could imagine, like these days, you could imagine you go back and look at the old, photographic plates or the old, data that you got from the CCD camera or, whatever. And you say, yeah, sure enough, that was Uranus. They saw it. And they mentioned it, right? I saw a star at such and such a place at such and such a time. We know what was there at that time. It was a planet, but they didn't know it was a planet. So they were looking at it, but they couldn't see a planet. They could only see either a star or a comet. So, I mean, this emphasizes the sense in which it's not exactly a different world, right? I mean, they were both looking at the same world. They just saw it differently. And Kuhn sometimes wants to say that, but other times he thinks that that's not satisfactory. Right? This is similar. Also, he says Galileo, looking at the swinging weight, saw a pendulum, whereas the Aristotelian, looking at the same swinging weight, saw a case of constrained fall. That's another time when Kuhn uses the same terminology. So that, like, it's not satisfactory because it's kind of, it would make sense if you said this about the playing card experiment, right? In a playing card experiment, the subject who's shown the black 4 of hearts is looking at the same thing the whole time, namely a black 4 of hearts. But at first they can't see a black 4 of hearts. Even when you show it long enough, they would be able to identify a normal card. Either they say it's a regular 4 of hearts, or they say it's a 4 of spades, or they say it's a weird four of hearts with like weird outlines or something. They can't see the black four of hearts. And then suddenly at some point, most people say, oh, it's a black four of hearts. And now they see the black four of hearts. But of course, the world didn't change, really. They were looking at the same thing, right? So, but Kuhn says, but see, in that experiment, like, why do we say they were looking at the same thing? Like, how do they know they were looking at the same thing? Well, the experimenter tells them, right? Like the psychologist who was running the experiment says, oh yeah, sure enough, it was the same card you were seeing this whole time. But in the case of paradigm change in science, there's no external authority. Right? There's no one like the experimenter here to step in and say, okay, you were both looking at this, but you saw this and you saw that. Like the only descriptions for what it is we're looking at are from within the paradigms. So that's why Kuhn thinks that this way of talking, which sounds better, or that sounds less weird anyway, it doesn't sound relativist. Sounds like, okay, yeah, we know there's a world. The world didn't really change. It's just the way we saw the world change. That Kuhn says this doesn't really get at it. This is basically Kuhn says that this is an anomalous fact from the point of view of our quote unquote Cartesian epistemological paradigm. Right? That our paradigm that we've inherited from Descartes. Now, again, wait, hold on a second. Epistemology is not a mature science, right? I mean, it's not like there's no competing schools and et cetera, et cetera. But still, yeah, again, he's now importing his explanation of the history of science into the history of epistemology and saying that Descartes started this paradigm according to which there's a difference between what you're looking at and what you're seeing. We interpret, it's kind of reasonable to attribute this to Descartes, I guess. We have some data and we interpret it, right? Like I take it to mean that the lump of wax is actually white. Misinterpretation according to Descartes, right? According to Descartes, bodies don't actually have colors. Colors are in the mind, right? So, but you know, I was looking at the same thing the whole time. It's just I didn't realize that all it has is extension and the modes of extension. So Kuhn says the paradigm that he's inherited for understanding the history of science, I think he thinks he's replacing with a new paradigm. But the paradigm of epistemology, I think he feels like we're in a crisis and he doesn't know what the new paradigm would be. But again, like, it's really weird and it's hard to reconcile. I mean, because the same thing I said at the end last time, although that didn't make it to the recordings, that you know, there's a tension between him seeming to say that this work under a paradigm is an unfree activity and you probably should quit it. Versus, on the other hand, seeming to say that he himself is engaged in it. And even saying that we need a new paradigm, which, like, his scientists don't say that. They don't say we need a new paradigm. They say we don't know what's going on. So, I mean, that whole thing is a little bit weird. But I just want to say one more thing. We're almost out of time, so maybe I should talk about this next time. I guess I just gesture at it this time since it is in the reading for this time, which is the analogy that Kuhn draws between scientific revolution and political revolution. This is on page 92 to 94, approximately, somewhere around there. I mean, he seems to think that the word revolution literally means political revolution, and it's been like transferred to scientific revolution. I'm not sure if that's right. But anyway, that's just a question about history of words. Um, but one way or the other, the question is there really an analogy there? And Kuhn says, yes, there is an analogy. The scientific revolution is a lot like a political revolution. And then to make this analogy out, he has to explain what a political revolution is like. So he says the revolution happens because the existing institutions have ceased to solve the problems that they themselves set. So that is, it's not because we have an external standard of justice, right? Like we hold these truths to be self-evident. It's not like we have an external standard of justice and we see that our political institutions aren't measuring up to it. Rather, it's the political institutions themselves imply that certain problems, they should be able to address certain problems, and that starts to fail. And then he says, like, uh, at some point, if this goes on long enough, someone somewhere will come up with a new way of organizing society. That's like the new paradigm, right? And then once that happens, people will divide it into camps, the ones defending the old society and the ones defending the new society. And they talk past each other. They're incommensurable because what each one is doing is illegal or unjust according to the other. And so how can their difference be solved? And Kuhn says, well, it can only be solved by the techniques of mass persuasion, often including force. Right? Like, so first of all, like, notice what that means about a scientific revolution. Kuhn is saying they're not, if you ask, well, how do we make the choice then? If there's two paradigms that are incommensurable, the answer is, well, whoever's stronger wins. Right? I mean, not necessarily physically stronger, because it's mostly other techniques of mass persuasion, but in the end, it could be physical force. So, I mean, we know they tried to use physical force against Galileo, right? Um, but second of all, what is this saying about political progress? Right? It sounds like political progress is not an activity aimed at making society more just, because there is no such standard. So whatever political progress is like, it's going to be like scientific progress and revolutions, and I guess we'll talk about that more next time. But it looks grim for it looks grim for the hopes of political utopia or something like that. All right. I will see you one more time on Thursday. Or, well, I guess I'll see you another time because of the final.